Hello everyone. This is the second of two tutorials on creating a lookat script in Unity 2022 to make an object point towards another one. Specifically, in the first part we analyzed the problem and implemented a solution that involved an instant rotation of the object. In this tutorial, however, we will create a slower and more gradual rotation, using quaternions and slurp. In this tutorial, I will assume you are familiar with concepts such as time.deltaTime and the quaternion.slurp method, as I have covered them in other tutorials. If you are not familiar with these topics, I recommend checking out those tutorials first. Before we go on, I remind you that, as it happens with most of my tutorials, the text version of this video tutorial is available for free download at the link provided in the description. In the previous tutorial, we discussed the global and local axis of the camera, both to identify the axis that indicates its orientation and to indicate the axis around which to perform rotations. We then reduced the problem to the two-dimensional plane and calculated the rotation angle around which to rotate the 3D model of the surveillance camera. In our script, this angle is called delta angle and is measured in degrees. To use slurp, we need three things: the quaternion that indicates the initial orientation, the quaternion that indicates the target orientation to be reached, a method to indicate at each frame of the game's execution at what point we are in a range from 0 to 1 in transitioning from the initial orientation to the final one. The first point is the simplest. The rotation property of transform, in fact, expresses the object's orientation in quaternions, so for this field we will use transform.rotation. The second point is not that complicated either. Given an initial orientation expressed in quaternions, the quaternion that expresses the target orientation obtained by rotating the initial one is given by the product of the initial orientation and the rotation to be performed. The rotation to be performed in our script is delta angle, which is expressed in degrees though. We need it to be expressed as a quaternion. Fortunately, the Euler function of the quaternion class is just what we need. It takes three parameters, i.e. the rotation angles around the x, y, and z axis, and returns a quaternion that represents this transformation. As mentioned earlier, to obtain the target quaternion we need to multiply the initial one by the rotation one, so in update I can write quaternion target rotation equals transform.rotation multiplied by quaternion.Euler 0f 0f delta angle. Right after, I can update the object's orientation by assigning the quaternion calculated by quaternion.slurp to transform.rotation with transform.rotation equals quaternion.slurp transform.rotation target rotation evaluation time. Obviously, now we need to define evaluation time, a float value between 0 and 1 that represents the points at which we are in transitioning from the initial orientation to the final one. First, I define and initialize this variable by writing private float evaluation time at the beginning of the script class, and evaluation time equals 0f inside the start function. The evaluation time variable must then be increased at each frame, which can be done by writing evaluation time plus equals time.deltaTime, right after the instruction containing slurp. This is, of course, just an example. My advice is to multiply time.deltaTime by a variable, whose value can be adjusted in real time in the inspector, until an optimal rotation speed is achieved. I discussed this topic in my tutorial on time.deltaTime. However, in this way, at some point evaluation time will reach 1.0, as it is incremented at each game frame without a reset option. But when should we reset it? The question can be posed this way. When are we ready to start a new rotation of the model? The answer is when the model is already pointing at the player, waiting for them to move. Normally, I would tell you that when the surveillance camera model points at the player and the player remains still, then delta angle equals 0 because there is no rotation to perform. However, with float values, especially in case of conversions between different units of measure, it is better to maintain a certain margin. So we will say that the animation is finished and a new one can start as soon as the player moves, when the absolute value of delta angle is less than 1f. So, right before the creation of target rotation, inside the update method, I write if matf.abs delta angle less than 1f, evaluation time equals 0f. Then I put the following three instructions, i.e. the definition of the target quaternion, the orientation change with SLERP, and the increment of evaluation time, inside the else block of this if statement. I save the modified script, return to the Unity editor, and press play to observe the result. In this case, the rotation speed is determined exclusively by time.deltaTime and can be decreased or increased, as previously mentioned, by multiplying time.deltaTime with a variable to be calibrated interactively. So, to recap, in this tutorial we have seen how to convert the rotation angle into quaternions to calculate the quaternion that represents the target orientation. And then we used the SLERP to perform slower rotations, whose speed can also be calibrated while keeping it independent of the execution platform, using time.deltaTime. We also defined a reset condition for SLERP so that the rotation restarts when the player is stationary and ready to move again. Okay, that's all for these two tutorials. See you soon!